Hello everybody, it's Mr. Mulvihill here. This is a review video for your test tomorrow in case you want more practice. So what I would recommend is getting a piece of paper and trying these examples out and then listening to my explanation. Okay, so here are the answers. In Buffalo, there's 3 inches on the ground already, and then it snows 2 inches per hour. So how much would there be after 4 hours? Well, it'd be 2 times 4, which is 8, plus the 3 they already have. So that would be 11. The rate of change is how much snow is increasing every hour. How much is the level of snow changing by? Well, it's 2 inches per hour. The initial value is 3. That's how much snow there is on the ground before the storm comes. And then to write an equation, it's going to be y equals the rate of change, which is 2, times x plus the initial value, which is 3. It's so important that we know this equation here. When we have to write equations, they're all going to look like that. All right, and then it says use your equation to find the total snow after 10 hours. So if we know the hours is 10, then all we have to do is plug in 10 for x plus 3, and you should get 23 inches. All right, for Syracuse, to find the rate of change from a table, we want to find the change in snow over the change in y over the change in x. So the snow we see increases by 6 inches, and that happens not in 1 hour, but in 2 hours. From 2 to 4 is a change of 2 hours. So if it snows 6 inches in 2 hours, we figure out that it snows 3 inches per hour, and that's the rate of change. And then if we know that it's been snowing at 3 inches every hour, then we can backtrack to find what it started at. It's not going to start at 0. There's already some snow on the ground. So if you had like time 1 here, 1 hour, we'd go back another 3, and we'd be at 8 inches. Because from 1 hour to hour 2, hour 1 to hour 2, the snow went up 3 inches. So we go back 3 from 11 to get 8. And then 0 hours, well, we got to go back another 3. Those 3 inches that are falling every hour haven't fallen yet, so we're going to take that away. That'd be 5. Our equation, it's going to be y equals the rate of change, which is 3, times x plus the initial value, which is 5. So then we want to use our equation to find how much snow after 10 hours. We're going to plug in 10, and you should get 35. For Albany, the rate of change is the number next to x, 0.5. The initial value is 4. What does the rate of change mean? In this case, it's inches per hour, 0.5 inches per hour. That's how fast the snow is falling. The initial value is 4. It's 4 inches on the ground before the storm. You know, if it storms again tonight, there's already like 8 inches on the ground before that new storm comes. And then our equation, well, we already have it, and we're just going to plug in 10 for x, and you should get 9. So those are some questions that you'll see tomorrow. Just go back to the video and rewatch it if you need more practice with it. Okay, you're also going to be asked to write the equation of a line from a graph. So if we have to write the equation of a line, again, our equation is going to be y equals rate of change times x plus initial value. So our question becomes, well, what is the rate of change? What is the initial value? So to figure the rate of change out on a graph, what you do is you start at the point on the left, and you go to the point on the right. So then you're going to do the process of rise over run. Rise over run. So to get from the point on the left, we're going to go down 2. That's our rise, and then it's kind of like you're falling. That's why it's negative. And then our run is 1, 2, 3, 4, 5. So then plugging it into our formula there, the rate of change will be negative 2 over 5. And then our initial value, we find that in the graph by looking where it crosses the y-axis. Where it crosses the y-axis is at 5. Right here. That's number 5. 1, 2, 3, 4, 5. And then our equation will simply be those numbers plugged into our formula. So y equals negative 2 over 5x plus 5. And the last thing that we're going to have to do after writing equations from graphs is go backwards, equations to graphs. Like in this question, y equals 3x minus 4, and we were to graph this. Again, the common theme, what's the rate of change, what's the initial value? That's going to help us out. The rate of change is the number next to x, it's 3. The initial value is the number next to the number by itself, which is negative 4. So how do we graph this? Well, we start with the initial value. We go to negative 4 on our graph and put a point. And then we use the rate of change to develop more points. And when there's a whole number, we got to put it over 1, so we know how much to run over. So we have our rise over our run. So we're going to rise 1, 2, 3, and then run 1 to get to our next point. And you do it again, up 3, right 1, put a point. And you keep going until you get a bunch of points. That line, you want to try to get your line through all the points, and it should, and if it doesn't, then you know you did something wrong. You want to put arrows on your graph and label it. And that's it. And then one more thing to point out is that sometimes we call the rate of change slope, how it's sloping up or down, and sometimes we call the initial value the y-intercept, because that's where we see it on the y-axis. All right, that's all I got. Please let me know if you need any help, and good luck tomorrow.